Thank you very much, Wouter, and the previous speakers for very interesting talks, and to Ignacio and to Eduardo for the invitation to speak today. I will just share with you very quickly some of our work on BIM-enabled lean production control systems, and this really has to do with digital twin construction. Some of it is associated with the work we are doing in the EU project called BIM to Twin. So fundamentally, when we talk about digital twins for construction, like for anything else, we have the real site on the left and perhaps some conceptual digital representation of that construction site on the right. But we're not talking only about the physical product, we're also talking about the process of construction. And so we have the fundamental links of monitoring what's going on and then operating the site from the digital twin. Now, the monitoring part of it is done with quite a wide range of technologies, some of which we're implementing in the project, but many are the topic of startup companies who are already active in the industry. The challenge today is that they each work individually and separately in a siloed form. So what we really have to do is not just acquire all of these monitored data feeds, but we also have to interpret them and merge them to create meaningful information rather than just the data. And that is quite a challenge to take object geometry, to take sensors of temperature, humidity, and so on, laser scans, photogrammetry, and all the rest, and convert them into meaningful object geometry, labor flows, material flows, equipment parts, and so on, so that we're able to interpret what actually was done. But if we're able to overcome this interpretation phase, we can establish what we call a project status model, the model of the as-built. And again, we see that some of these technologies exist, sensors embedded in the concrete to determine temperature, which can enable us to forecast the time we can strip the forms, reporting of activities done and not done using 3D cameras, laser scanning, and simple applications where workers report what they have done. Here are just some very quick examples of these technologies that exist and are being used. This one is from a company called OpenSpace AI, but there are others. There's one, for example, called BuildDots, and the way they work is 360-degree photography and then photogrammetry to compare with the BIM model. You can see it here, for example, from BuildDots, the position of the camera taken, the view of the wall, and then comparison between the BIM model on the right, which represents the design intent, and on the left, what actually is there now, with a layout then saying, oh, but clearly the wall should already have been closed by this point in time, and yet it's not, which is then a meaningful conclusion about the situation on the site. There are others like this one, where people monitor tower cranes and they're able to learn things about the building based on the camera, on the monitoring of the hook on the crane. And in the reverse direction too, we're able now to take, and we have tools for laser display, for example, as you see here on the floor, of the building model directly onto the work surface, which creates this two-way communication of information from the BIM back onto the construction site. And the underlying theme that I want to emphasize here is this lean production control. And one of the central tenets within lean is this idea of doing plan, do, check, and act. This is something called the Deming cycle, and it's really central to a lot of the way that we control production in live systems using lean construction principles. And what I want to do for you is show you how we map this iterative plan, do, check, act cycle as a management tool onto our digital twins and how we use the digital twin to implement that. So if I take this plan, do, check, act and translate it into equivalent terms for construction, I could say that the planning is actually modeling of a building digitally using BIM to establish design intent and using tools for construction planning. And then building, which is fabrication off-site and construction on-site, monitoring and interpreting that data through all those monitoring tools I showed you before, and then evaluating and improving, which then feeds back into another cycle of modeling, because the assumption is that we only build what we model first. Now, what I'm showing you here is the basic architecture of the BIM to twin system, and it emphasizes everything I've said so far. So we have here on the right hand the physical twin. We build it through controlling the construction. We monitor it down here, and then we get the raw monitored data. We interpret it. We create the project status model, and then we compare the project status information with the project's intent, information, and knowledge. And having done that, we then predict performance, evaluate feedback for new design, create new design, replan the process, and feed that back to the building. So you can see here that this is, in fact, an embodiment of our plan, do, check, act cycle. If I lay it out, then we have here the planning, as we design the product and we plan the process, the building, where we control the construction day by day, we monitor it. We then, in these three, interpret, evaluate, and predict, meaning we then act, and then feed back into the design, product, and planning process cycle. And that can be, in terms of time, it can be monthly, but nowadays it can be weekly, daily, or even hourly feedback and adaptations. So what we're aiming for, both in the project and in industry, and certainly in academic research, is rather than saying digital twins for construction, we believe that this gives birth to a really new paradigm, which we might call digital twin construction, because our ability to have short cycle times of monitoring, of plan, do, check, act, means that we can do things with far greater agility than we're able to in current methods. And that leads us to many, many possibilities also of business opportunities. Already today, we see systems like this where people can run control rooms for construction projects, production control rooms, not design control rooms. And this is an example from a data center built in Ireland. But you see here not only schedules, models, and details, but when the team meet in the space, it's all of the subcontractors, all of the implementers meeting to decide what should be done. And some of those decisions, once they become automated through AI or through other tools, we may then begin to see an opportunity for a platform business to run multiple projects from control rooms in this way. And so we're talking about digital twins with product and process that function as systems within systems, but primarily digital twin construction, what's new is that it is entirely an information process. And so it has challenges, of course, and it has information and process challenges. And I should simply sign off and recognize the BIM to Twin project as well, and invite you all to look for more information about the project on its website. Thank you very much.